All right, today we're going to go on a journey. And it's a fascinating one because it starts with a subject we all remember from school, and it ends with the incredibly powerful AI that is literally changing our world. So let's get right into it. I mean, think about it for a second. You start typing a message, and boom, your phone just knows. It knows exactly what you're about to say. It honestly feels like a little bit of magic, but it's not. It's some seriously brilliant technology at work. And that's the secret right there. The whole thing is called natural language processing. And the craziest part, the journey to teach a machine to write like a person, well, it's rooted in a place you'd probably never expect. We're going to connect all the dots, from basic math all the way to today's most advanced AI. So let's start at square one. This entire field is built on one single, incredibly ambitious idea. Can we teach computers to understand and actually use our language? With all of its quirks, its context, and its creativity. Okay, so here's the more formal definition. NLP is basically this meeting point, this perfect fusion of computer science and machine learning. And the goal, really, isn't just for computers to recognize words. It's for them to truly get the meaning and to even create new, coherent sentences all on their own. So, how on earth do you get a machine, which, remember, only thinks in ones and zeros, to understand something like a poem or even just a simple email? Well, the answer, believe it or not, lies in a powerful toolkit made of math and statistics. And here it is, the most crucial point. We have to translate our world of words into the computer's world of numbers. Things like linear algebra and probability, they stop being these abstract concepts from a textbook. Here, they become the fundamental rules, the actual grammar that lets a machine process language. Let's start with the absolute most basic building block. It's called a scalar, and it's really simple. It's just a single number. So in the world of NLP, a scalar could represent something easy but really important, like how many times the word learning shows up in an article. Okay, now we take those individual numbers, those scalars, and we can group them into a list. And that's called a vector. Now, here's where it gets really interesting. A vector can start to capture the vibe of a word by holding a bunch of its characteristics all at once. Things like how often it appears, and maybe even if it has a positive or negative feeling, what we call its sentiment. And this, right here, this is the giant leap. This is the magic trick. By turning words into these vectors of numbers, we've basically translated the messy, beautiful concept of language into a structured, numerical format. It's a process called embedding, and it's what makes everything else we're about to talk about possible. The computer finally has something it can actually work with. Okay, so we've got our words as numbers. Now what? Well, now we can start building the engines that do all the heavy lifting, the machine learning models that can make sense of all this data and give us some really useful results. But hold on, not so fast. You can't just toss a whole novel at a machine learning model and expect it to work. Real-world text is messy. It's full of punctuation, weird capitalization, and all sorts of other noise that can totally confuse an algorithm. So the first, and I mean essential step, is to clean it all up. And this cleaning process, it's like a pipeline, a little assembly line. First, we make everything lowercase, so the and the are treated exactly the same. Then we get rid of stuff like commas and periods. And then we get even more advanced. Tagging words as nouns or verbs, that's called POS tagging. And even identifying names of people or places, which is NER. Every single step standardizes the data, making it just perfect for analysis. So, with our now squeaky clean vectorized data, we can finally train our models. This is where that magic we talked about earlier really starts to happen. We can teach a model to classify an email as spam or not, analyze thousands of product reviews to see if they're positive or negative, or even do something as complex as translating between languages. And that whole journey, from basic math to vectors to these powerful models, well, it has led us to the absolute cutting edge of this entire field. You could say we've reached the summit. Large language models. This quote from a review of the book this explainer is based on, it just perfectly captures the excitement. These models aren't just one more step in the process. They are a huge leap forward in our ability to navigate and use language with AI. So what makes a large language model, well, large? It's not just a small improvement. It really comes down to three things. One, the absolutely massive amount of data they are trained on. 2, their incredibly advanced internal architecture. And 3, their mind-blowing ability to handle a huge variety of tasks without having to be specifically retrained for each one. And just to put that scale into perspective, the publisher of the book we're talking about today has over 7,000 titles in their digital library. That is a ton of information. But an LLM, it's trained on a dataset that makes that entire library look like a tiny pamphlet. We're talking about a huge chunk of the entire internet. So we've followed the path all the way from a single number to these massive AI models. But let's bring it all back down to earth. Why does any of this matter? What does going on this journey actually empower us to do? Here's the key takeaway. This is not just some theoretical exercise for a classroom, no way. Every single concept we've touched on, from linear algebra to LLMs, has a direct, practical application. It's all about using tools, like the Python programming language, to build real solutions that solve real problems. And this slide really says it all. I mean, look at the power this knowledge gives you. You can truly master the foundations, prep data like a pro, build systems from the ground up, understand today's most complex models, and even start to see where all of this is going next. It's basically a complete toolkit for the age of AI. And really, that's what I want to leave you with. For the first time in history, we're building tools that don't just calculate numbers for us. They can communicate with us in our own language. That barrier between human thought and machine logic is starting to dissolve. So the question is no longer if we can talk to machines, it's what are we going to talk about?